This device was made in Germany, and it was designed to perfectly convert solar radiation into heat during the winter months. These tubes are a path for the circulation of liquid, which is heated by solar radiation to almost 100 degrees, so that this thermal energy heats a house. This concave mirror directs the solar radiation onto the tubes, and now we will see how the mirror focuses the radiation here. In addition, several tens of percent of solar energy comes to the tubes in this way, without the help of the mirror, directly from the sun. I made cheap analogues of that solar heater, and this is the first of them, where this mirror directs solar radiation to this polymer absorber, through which water must circulate. This is another option which is almost 100 times cheaper than such conventional solar collectors, and we see that I replaced that glass mirror with this cheap reflective film. Here we see focused solar radiation, and I made this concave mirror from stainless steel sheets. This snow helps us understand why it was necessary to install this transparent sheet. Many engineers will object to the design of tubes, which consist of this thin copper tube and a transparent cylinder. In addition, home craftsmen understand the complexity of making such tubes and this mirror. So let's replace these tubes with something like this layer of cheap pipes, which should be installed here. In addition, these are mirror surfaces of any shape. This is a sheet of glass, and this is thermal insulation with a thickness of 5 or 10 centimeters. These surfaces must be black, and these walls must have thermal insulation with a thickness of up to several centimeters, which reduces this heat loss because the temperature here will be about 20 degrees higher than the ambient temperature when the sun is shining. If the west-east line is here, we do not need to move the mirrors according to the movements of the sun. You already understand that the large mirrors should focus solar radiation in this way. This radiation from the mirror and directly from the sun is absorbed by the black pipes and hits their walls, which hit the antifreeze liquid that circulates through the pipes. Few solar photons pass through the gaps between the pipes, but these mirrors direct them to the lower surfaces of the pipes. This my experiment will help you understand how this part of solar radiation from this mirror moves from morning to evening of one day, and these are its points in time. You may notice that this path slowly shifting in this direction until the afternoon, but after that this path slowly shifting in the opposite direction, away from the mirror. It was midday in December, but this is the situation at the beginning of the heating season, in October, when the sun is 15 degrees above its December position. That is why this flow of energy from the sun increases almost twofold, but unfortunately this flow from the mirror will decrease by about 1.5 times. Then this flow will increase day by day until this situation at the winter solstice on the 22nd of December. After this, the flow gradually decreases due to the increasing height of the sun above the horizon, and the same situation of a decrease in the flow by 1.5 times will be at the end of February. This is the situation at the end of the heating season, in the second half of April, when solar photons do not reach the surface of the mirror, but this flow directly from the sun is good. After this, increasing the height of the sun reduces this flow due to this edge, and this is the situation from May to July, when the sun is so high that the flow does not reach these pipes. Let's place our house here near the American city of Santa Fe, and this is its climate during the heating season, and here we see that the winter is very sunny. But here we see that the winter is cold, and these temperatures form such heating needs of a house with an area of 100 square meters. These kilowatt-hours of heat must be produced by several solar heaters, which heat 3 tons of water inside such tanks during the solar hours, and this thermal energy will heat the house not only during the day but also at night and on cloudy days. This is the number of sunny days for different months, and this is the heat production from 77 square meters of our solar heaters if their pipes are coated with cheap black paint rather than a selective coating. These kilowatt-hours of heat are enough to cover the heating needs of December and January with this small surplus, but this excess heat of the remaining months is noticeably greater. 77 square meters of solar heaters is almost 20 such devices with 4 square meters of area of this transparent sheet. This is the total construction cost of the entire system, and here I wrote 1.5 times more expensive than this cost of materials for home production of one solar heater. Unfortunately, the home production will be complicated by the fact that this mirror shape will be different for different geographical latitudes, duration of the heating season, and other climate features.